This is the Vitodens 100 B1HA KA service and maintenance. So, like Drew said, I come from tech service. So, we used to get a lot of calls on the B1HA KA. So, I thought it would be a good idea to do a service and maintenance on these. So, thank you all for coming in and jumping in on this. Let's jump right into it. So here's some learning objectives here. We want to be able to explain how to remove the burner. We'll go over that and proper cleaning techniques. We'll also list some recommended chemicals and tools to clean our heat exchangers. All right. And then we should be able to identify 2 maintenance tips to avoid condensate backup. If you've been with Viessmann for a while, you know that condensate backup is not something that we want to see. So if anybody has seen this, this is right out of our manual. This is the advice to the owner. And one thing that I want to point out here is this last line. So the need for professional service before the heating season begins. A lot of people ask, how often should we service our boilers? Right out of the manual, it says once a year before the heating season. We're not too picky on that. It could be before heating season or after heating season, just as long as it's before once a year. If anybody's ever seen this before, if you don't schedule time for maintenance, your equipment will schedule it for you. This goes for any piece of equipment. Okay, this goes for a vehicle, right? If you don't do oil changes and things like that in your vehicle, eventually you'll be stranded on the side of the road. So this goes for any piece of equipment that we have. So maintenance is very important when it comes to equipment. What are some required tools to service our boiler? So we want an adjustable wrench. We can use our Viessmann cleaning tool. That is the part number here. Okay. Hard bristle nylon brush sets. We don't want any type of hard metal bristles or anything like that. So a hard bristle nylon, some water, some Axiom Clean F steel or CitraSurf 77, a torque spit set. We want our combustion analyzer to check combustion, or a manometer to check gas pressure, a wet and dry vacuum, Allen keys, 8mm and 4mm, and we'll get into why those Allen keys are important later on, and a multimeter. Additionally, it would be nice to have a 3/8 flathead screwdriver, a Phillips head screwdriver, and descaler for our heat exchangers. Whether you have a combi unit or non-combi, we want to descale the heat exchanger. We do sell a Viessmann toolkit. That is the current part number here. We do sell that. That comes with any type of torque spit you would need and things like that to get into the heat exchanger. We do have a service kit for the B1HA KA. This is the part number, the current part number for that service kit, and that's good for North America. I really couldn't show the scale of how big this part is, so I kind of used a box cutter here to kind of give you a representation of how big it is. It's not very big. I recommend, if you're going to go service a B1HA KA, to go to your wholesaler, get one of these, and if you don't need anything in this kit, it fits conveniently inside of the boiler itself. So that way, if somebody gets a call at midnight and they don't have an igniter, they have that parts kit there, and that comes with an igniter. So just to go over what comes in here, we have our door gasket here. We have our ignition ionization electrode all in one here with our gasket and replacement screws for that. And then we also have a gasket for our gas connection as well. We have that little fiber washer in there in case that's damaged or get lost, or has gotten lost over the service. Then we have that to replace that as well. And then this is just an instruction booklet that comes with it. This is part one of what we want to do on a routine maintenance, and we'll dive deeper into each one of these points. So first of all, turning off the power, of course, closing the gas supply, taking an overlook of the boiler components for any issues like condensate leaks or flue gas recirculation, wire conditions, if there's any loose wiring or anything like that. Then we want to disconnect and remove the burner, check the electrodes and the gaps on those electrodes, remove the target refractory and baffle, and then inspect and clean the heat exchanger. So let's dive deeper into each one of these parts and how we do those parts or do these steps. First off, turning off the power. So if you've ever seen a B1HA KA, we have a little button here. And the button pressed in means that the control is on. And if it is retracted or depressed, that means it's in the off position. Or you can look at the 1 and 0 here. All right. How do we remove the door off of this boiler? So remember I said that you'll need this Phillips head screwdriver. You'll take that, and there's 2 screws on the left and right hand side, right underneath the control here. You'll back those out. Once you back them out completely, they'll actually drop and hang underneath the control. They won't drop completely out, but they'll just drop and hang there, and that then that screw is completely backed out. Once that's done, we'll just remove the front cover and set that off to the side. How do we fold down our control? Get that completely out of the way so we can get in here and service this boiler. So we have 2 little button clips here that will push to the left and right hand side. Then our control will fold down. And then I recommend putting a plastic bag over this control. Let's say we have standing water inside of that heat exchanger, maybe from condensate backup, for instance. We don't want to remove that combustion chamber door and get water on this control. All right. You'll be calling tech support about, why the control isn't turning back on. It's because those control boards have gotten wet from that and have fried that control. So save yourself the headache, get a plastic bag or something along those lines and put that over that control. After that, we're going to do a visual check. All right. If we see anything like over on this picture, we got some signs of flue gas recirculation. Okay. We want to check for water marks, any standing water, maybe some water has dripped on the gas valve, anything that would cause initial concern as soon as we open up this cabinet. We want to check for any dry rotted plugs or wires. If your plugs are discolored or dry rotted, that's also signs of flue gas recirculation. And then check for any condensate leaks, anything that's actively leaking or actively dripping. We want to make sure that we're going to have the tools on hand to be able to fix this and repair this so the customer has heat or hot water. Let's talk about removing the burner. First step, we have 2 plugs on our burner fan. We have incoming voltage here on the 100 plug, which is reflected here. And then we have modulating voltage on our 100 alpha plug. We'll have to remove both of those plugs. Just a heads up, on this plug, on the 100 alpha plug, there is a little clip that may have been broken off just over the years of service. If it's not, then you'll have to pull this out and then remove that 100A, or you'll be sitting there and pulling that harness. We don't want to damage that plug. Then we'll remove the 35 plug off of the gas valve, as you can see here. That is keyed, so we can't put it in backwards. You can see the key here. And then we'll remove the spade connector for the ground. Just pull that right off, and then pull off our ignition and ionization cable as well. After that, we'll remove the brass nut using our crescent wrench. And remember, I said that little washer, make sure we don't lose that little washer. We set that off to the side, or, put it in a place where we'll remember. All right. Once we got all those plugs out of the way, then we will remove 4 T30 screws, hex head screws. Once that's done, this whole assembly pulls out from the heat exchanger. So that is our gas valve, our radial fan, and our door. Get that right out of the way. Then we can check our electrode gaps. Now remember, I said those Allen keys will come in handy later on in the presentation. This is where we'll be able to do a quick check with those Allen keys. The 8mm should fit nicely in between the ignition electrode and the burner. And then the 4mm should fit between the ionization and the ignition here, the spark. All right. This is the part number. If you just need an electrode and you didn't want the whole service kit, this is the part number for that electrode. We don't want to use any metal brushes on this. All right. It'll score up the coating that's on these electrodes. If it's really fouled up, I just recommend replacing it. We want to check our refractories for any major cracks. And when I say major cracks, cracks that go all the way through that refractory. All right. Any water damage, you'll see a white mark along this. If we see any white marks where water may have been sitting, we know we have condensate or a condensate issue that needs to be addressed. But then this refractory also needs to be replaced. Once these refractories get wet, they will crumble. Okay, they are wearable parts. We want to check our burner gasket, our door gasket, for any cracks or dry rotting, and we can remove that. There's a little cutout here that we can pull that right off. One way to check it for a good door gasket is you ball it up in your hands, and if you throw it out onto the floor, onto a table, it should spring back to life. If it springs back to life, then that gasket can be used again, as long as there's no rips or tears in it. Removing the burner assembly so we can check the burner tube, there's 2 T25 bolts on either side of this burner. Okay, you'll remove those, and this refractory will pop off. Once you remove that refractory, you can actually see if a crack goes all the way through. Maybe you couldn't tell with the refractory all on, but now with it removed, we can see, hey, does this go all the way through to the backside? Once that is removed, there's 2 more T25 screws. I kind of tried my best pointing them out here. You'll remove those 2 screws, and then we can check the burner tube gasket. This is a pretty rigid gasket. It shouldn't have to be replaced. So we're just checking it to see if there's any wear and tear on that gasket. Now we can look at the burner tube. We want to check for dirt and debris on this burner tube. Okay, I've seen sometimes bees or different things like that in here, right? We want to make sure we remove any debris that we can see inside this burner tube. We can use compressed air to blow it out. So there's multiple layers on this burner tube. Unlike our new E-Series, our new E-Series doesn't have multiple layers. It's just laser cut. This is the older generation, so it has multiple layers. We have an inner layer, we have an outer layer, and then we have layers in between. If we have a dirty room, right, we can suck up different dirt and stuff like that, debris into this. So just blowing it out with compressed air. We don't want to use wire brushes or anything like that on it. That will damage the burner tube. We don't want to do that. All right. Then we want to check our venturi. Our venturi, like the picture that I showed earlier, if it's 8 out or it's brittle and cracked and breaking, that's signs of flue gas recirculation. Okay, that has to be addressed before we're done doing a service and maintenance on this. But make sure that it's in good working order. And then we could also then check the fan for any sort of debris. All right. So if there's, build up or something like that inside that fan, we can use compressed air and try to get that out. Make sure our vanes look good and different things of that nature. We also have an inlet screen on our gas valve that we want to check. All right. Make sure that there's no debris in there that may cause gas pressure issues once we put this back together. Just make sure that that's clean. Now let's go into cleaning the heat exchanger. We'll use that vacuum that we brought to remove any sort of debris that's inside of that heat exchanger. And then we want to then take a soft bristle brush like I have here, or maybe you can use your drill attachment. A toilet bowl brush works just as fine as well. And then we can brush down that heat exchanger as well while vacuuming. If we have any sort of stubborn debris inside the heat exchanger, we can use a cleaning agent, but they must not contain hydrocarbon-based solvents or potassium. Okay. These two we recommend CitraSurf 77. If you can get that, that's great. If you can't, maybe look for Axotherm Clean F Steel. Okay, either one of those are fine. Just follow the manufacturer's instructions when doing that. Then we'll spray those down, and then we'll rinse with water to make sure there's no debris left in there. But before spraying any chemicals or spraying with water, again, remember I talked about the refractory. We don't want to get those wet. We have to remove this rear refractory. We already removed the front refractory at the beginning when we removed the door off of the burner. So now we want to remove this rear refractory. That's pretty simple. Just take this center bolt out or nut, remove that, and then this refractory will pull out of this heat exchanger. Then we can spray down like we see in this picture on the right. If we still have an issue with buildup in between our heat exchanger coils, we may need to use our cleaning tool. And this is it in action, okay? We don't want to scrape with that cleaning tool. We want to punch down through the heat exchanger. Now, there are spacers in between the heat exchanger. So once we hit one of those dimples, we just jump over and go right to the next section, okay? We don't want to scrape again. People sometimes ask me why this piece of metal is so flimsy with the cleaning tool. And I explained to them that it's made out of the same stainless steel as our heat exchanger. So we're not putting in two dissimilar metals, and it is pretty durable. It does come with replacement blades. As this one gets dull, you can replace it. But it's a nice tool to have to get in between these heat exchanger coils. Here's some pictures of poorly maintained heat exchangers. As we can see, this is those white marks I was talking about on that rear refractory there. Okay, we can see that this is kind of wet here as well currently. But we see all of these, what I call coffee grounds or products of combustion, that are laying here and not allowing for condensate to freely flow through our passageways. Here's a kind of a worse one, right? So this one's actually really bad here. We see that the front refractory has now started crumbling. That's what this is. And that rear refractory is in real bad shape, just absolutely crumbling. Again, this is from water damage, condensate backup, and just not maintaining our boilers properly. And here's a really bad one as well. Okay. We definitely can tell that this has probably never been maintained, and we want to stay away from our heat exchangers looking this way. That's why we recommend servicing them on a yearly basis. If we run into one of these heat exchangers this way, we want to take a look at that rear baffle. Now, how do we get to the rear baffle? So if we get a heat exchanger like this and hasn't been maintained or hasn't been set up properly as far as propane or natural gas, this baffle can get damaged. All right, so this is why we want to check this. We'll remove that rear bolt like I discussed earlier when removing it and using chemicals or water. Then there are 6 bolts that go around that baffle plate. Normally, when I worked in the tech service department, these screws would sometimes be missing if there was a improperly set up heat exchanger, or hasn't been cleaned or serviced. So if you automatically see one of those, then we know that the baffle is more than likely damaged. But we'll want to remove these 6 screws here, and then that exposes the baffle. This is what the baffle should look like, right? We have fire caulking here. It's not bent or warped in any way. The exhaust flue isn't damaged. So this is what we're looking for. Now we'll go over our maintenance part 2. Okay, so after we did all that, now we'll go over these things and then we'll deep dive into each one of these bullet points. So we'll have to reinstall everything, of course, clean our condensate trap, and then look at our neutralizer if we have one. Look at those pellets, make sure that they're clean, make sure that they're to the proper level. Reprime our condensate trap if we have to, and then we'll do an emissions test. All right. How we get this condensate trap out of here is there's a little condensate hose that runs from the heat exchanger to our trap that pulls right off, and this pulls right out. Then we can flush that if there's any type of debris in that condensate trap or anything like that. We can flush that and then fill it and reinstall. And then we've been talking a lot about condensate backup. We don't want a double trap, right? We already give you a trap. We don't want 2 of them. So make sure that we have an air gap here in between our dishwasher hose. That's what I like to call it, but it looks like a dishwasher hose, but it's our condensate hose. Make sure that there's an air gap there, and where it terminates, if it terminates into a condensate pump, over time, this hose can stretch. Maybe last year when you checked it, it wasn't below the water level. It may now be below the water level. So just make sure that our condensate hose isn't below the water level in that condensate pump, because that will also cause a trap. All right. Make sure that there's no bends or loop-de-loops in that condensate hose as well. Cleaning this, our flat plate heat exchanger. So if we have a flat plate, we want to make sure that we clean it. There are multiple ways that we can do that. But if we have to remove this, as you can see, these passageways here are very tight. So we want to make sure that we get any sort of buildup or anything out of this heat exchanger. And we can remove that with 2 bolts, and then this pulls right out. There are some gaskets here that may need to be replaced. So if you are going to pull this heat exchanger, flat plate heat exchanger, just make sure you have that on hand. And then we can just soak it in non-toxic solution, rinse and reinstall it. This is if we actually had, my recommendation, if you have a combi, I would recommend putting in some ball valves and some purge valves as well. The reason for that is because then you don't have to remove that flat plate heat exchanger. You can hook up your descaler pump right to this and then pump through that heat exchanger on the domestic side using, water and vinegar or whatever to be able to flush that out properly. This is the easier way to do things. If we need to flush our heat exchanger, we recommend doing that every 2 to 3 years. We'll just go right through our boiler fill valve, right to our boiler drain, hook up our heat exchanger, flushing cart to it, flush this heat exchanger out. If we have an HA with an indirect, same thing applies. We'll just have to move that diverter valve to the domestic hot water position to be able to flush the domestic hot water coil as well. Cleaning our neutralizer here. So we want to free up and rinse the pellets. Your pellets may look like this. That's perfectly fine. That's just products of combustion in there. But we can free these up. We can rinse those pellets if needed. If there should be a fill line in here, if it's below that fill line, make sure we top off those pellets with fresh ones. We also want to replace those pellets if we're not getting 7 to 8 pH on the outlet side. So that's one thing to check as well on a yearly service, is make sure that our pH on the outlet of this neutralizer is between 7 and 8 pH. If it's not, then those pellets need to be replaced. If we need to service our pump for any way, if maybe we're having a flow issue or we're troubleshooting something, we can actually remove this little coin plug here on the rear of the pump using that 3/8 slotted screwdriver. Water won't shoot across the room. There will be a little trickle of water coming out of this pump, so make sure you put a towel down underneath of it or a little cup to catch it. But we can actually remove this whole this coin vent or this coin plug here, and then we can stick a screwdriver in there. We can actually see the shaft of the pump. If we stick a screwdriver in there, we can actually turn that pump to make sure that it's free and it's not seized in any way. Let's go into emissions test and relay test. Okay, the best way to check gas pressure and the best way to check for emissions is through relay test. Instead of just turning on a thermostat and the boiler just goes to whatever set point, at least we know we have a minimum and we have a maximum range here. How we do that is we select mode on the control. We'll tap that. We'll select the up arrow until serve is flashing. And then we'll hit OK. After that, we'll hit the up arrow. And then it'll say 20%. So that is our low fire. We can then check gas pressure, check our gas pressure drop from static to low fire. And then we can also do a combustion analysis, and we'll talk about that a little bit later. But then we can also hit the up arrow until 100% comes on the screen here. And that is now high fire. So we have low fire and high fire. We can select these arrows to go up and back. If you wanted to do high fire first, you can just go hit the up arrow until all of these bars are full down here. As you can see, 20 is 20%. This one bar is lit. 100%, all the bars are full. Okay. If we want to back out of relay test, we have to power cycle. So we'll turn the control off and then we'll turn it back on. What are we looking for with gas pressure? Okay. We'll loosen this little needle valve here on the left-hand side of that gas valve. And then we'll put our manometer there, open the gas valve to check static gas pressure. Then we'll fire the boiler through that actuator test like we talked about just in the previous slide to check what our gas pressure drop is. If we're on natural gas, 4 to 14 inches of water column. If we're on propane, 10 to 14 inches of water column. Now, that does not mean we can start at a static gas pressure of 14 inches and in high fire drop to 4 inches. We don't want to see more than a 1-inch gas pressure drop from static to high fire. The reason being is because if we're dropping that much, the flame will flutter on the burner tube, dance away from that ionization electrode, and you'll get faults on the boiler. Also, an intermittent issue that could happen is if there's any other gas appliances on this gas train, we want to make sure that those are on as well when we're checking gas pressure issues. If we have a boiler that's, and this goes for any Viessmann, if we have a boiler that's locking out intermittently on a gas pressure issue, and there's multiple appliances on this gas train, it could be something where the customer is doing dishes and cooking at the same time, or doing dishes and laundry or whatever, and then the boiler goes into high fire, and then now we don't have enough gas to supply our demand. So again, checking with those appliances on and running, and also doing a gas pressure check will help us determine if there's a gas pressure issue and determine what our actual drop is in the worst case scenario. Checking our emissions. So we have our combustion air port here, and then we have our flue gas measurement port. Here's our CO readings for natural gas, and then for LP as well on the bottom here. And you can find these all right in the manual, but this is what we're looking for here. This is a really easy graph here. We want to wait for the burner to start and allow it to warm up for a minute before we put our analyzer in to check for CO2. As soon as this boiler fires off, if we have our analyzer in here, you'll get really crazy spike readings. So we want to wait a couple minutes for everything to kind of like level out, and then check our emissions. We want to check for any sort of flue gas recirculation. I know I've been talking a lot about that through this presentation, but it's something that basically kills our boilers. Okay, if we have flue gas recirculation, it will take out components very quickly. One way to do that, we can put our analyzer in our combustion measurement port. And then what we're looking for here is CO2 concentration should not be greater than 0.2%. Our O2 should be greater than 20.6%. And that determines whether we have flue gas recirculation or not. Now, there are gaskets underneath of this port. One of those over time may have gotten rolled when we installed venting or just have gone bad over the years. One thing we want to check is we have a little port underneath of the boiler, right? All this is gasketed off. You would put the door back on in both of these instances. If the door's off, we're not really reading for flue gas recirc. We're just pulling air in from the space. So make sure the door is on. But to check those gaskets underneath of that test port, there's a little gasket here that we can pop out, put our hose in, and then we're actually reading inside of the cabinet and see if there's any leak under that test port that we just tested at. So if you don't see a reading, but you see signs of flue gas recirculation when you go out to maintain this boiler, and you don't get a reading, CO2 reading in the fresh air intake, it could be something underneath of that. So then we would go underneath of the boiler and then check here. All right, that'll be our second check. If we have CO2 in the cabinet, then we know that one of those gaskets underneath of there has gotten bad or whatever the case may be, and then we can troubleshoot that. And those are replaceable gaskets. You can get those at your local wholesaler. So just to kind of touch on everything here, we went over how to remove the burner assembly and some proper cleaning techniques with the brushes, with the cleaning tool. We also went over chemicals, what chemicals we can use, what chemicals we can't, and how to clean that heat exchanger. And then we also talked about how to avoid condensate backup. Thank you, everybody, for coming out.
All right. Have a good day, everybody.
See you.